In this lesson, we will delve into a key aspect of Project 4 concerning the selection of boring sleeves and supports for boring machine fixtures, specifically the types and selection of boring sleeves. We will explore the various types of boring sleeves, their respective characteristics, and how to accurately select the appropriate boring sleeve based on different requirements in practical applications. Additionally, we will examine real-world cases from the aerospace and the civilian sectors to appreciate the system thinking involved in precise matching. In the design and the application of boring machine fixtures, boring sleeves play a crucial role. They are primarily used to guide the boring bar, ensuring the accuracy and the quality of the bored holes. Next, we will provide a detailed introduction to the types and the selection of boring sleeves. Types of boring sleeves. Boring sleeves are mainly divided into two categories: fixed boring sleeves and rotating boring sleeves. Fixed boring sleeves. The characteristic of fixed boring sleeves is that they do not rotate with the boring bar during use, but are instead fixed to the boring jig frame. They have a simple structure, are easy to manufacture, and are cost-effective. Based on their structural form, they can be further subdivided into Type A and Type B. Type A fixed boring sleeve. This type of sleeve has a notch on its outer circle and is fixed to the boring jig frame with screws. It is suitable for low-speed boring operations because, at low speeds, the friction-generated heat between the boring bar and the sleeve is minimal, preventing significant damage to both the sleeve and the bar. For example, in some general machining workshops, Type A fixed boring sleeves are often used for parts processing where the precision requirements are not particularly high and the boring speed is relatively slow. Type B fixed boring sleeve. Unlike Type A, the Type B fixed boring sleeve does not have a notch on its outer circle. Instead, it is installed in the hole of the boring jig frame through an interference fit. It offers higher positioning accuracy and is suitable for applications requiring high precision in boring. For instance, in the boring of precision molds, Type B fixed boring sleeves are preferred to ensure the accuracy and quality of the molds. However, fixed boring sleeves also have their limitations. Since the boring bar slides within the sleeve, high boring speeds can generate significant heat due to friction between the bar and the sleeve. This can lead to increased wear on the sleeve, affecting the accuracy and surface quality of the bored hole. Therefore, they are generally suitable for applications with lower boring speeds. Nu is less than 20 meters per minute. Rotating boring sleeves. Rotating boring sleeves rotate together with the boring bar during operation, thus avoiding relative sliding between the bar and the sleeve. This reduces friction and wear, making them suitable for high-speed boring applications. V is greater than 20 meters per minute. Based on their structure and working principle, rotating boring sleeves can be further divided into several types. Sliding bearing type rotating boring sleeve. This type of sleeve uses a sliding bearing fit between its inner hole and the boring bar, utilizing lubricating oil to reduce friction and wear. It has a compact structure and offers high rotational accuracy, but it requires good lubrication and cooling conditions. In some high-speed boring automated production lines, sliding bearing type rotating boring sleeves are widely used. For example, in the boring of automotive engine blocks, this type of sleeve is employed to enhance production efficiency and machining precision. Rolling bearing type rotating boring sleeve. This type of sleeve is mounted on rolling bearings, achieving rotation through the rolling of the bearings. Rolling bearing type rotating boring sleeves have a low friction coefficient and high rotational speed, making them suitable for high-speed, heavy-load boring applications. In the aerospace industry, for the boring of some large aircraft engine components, where extremely high demands on machining precision and efficiency are required, rolling bearing type rotating boring sleeves are used. Selection of boring sleeves. In practical applications, selecting the appropriate boring sleeve requires considering multiple factors based on the characteristics of various types of boring sleeves, such as adaptability to rotational speed, load-bearing capacity, and the lubrication requirements. Machining precision requirements. If high precision is required for the boring, such as dimensional accuracy reaching IT6, IT7 levels, and surface roughness standards, rotating boring sleeves should be prioritized. This is because rotating boring sleeves can reduce friction and wear between the boring bar and the sleeve, ensuring the accuracy and surface quality of the bored hole. For example, in the aerospace sector, for the boring of some critical components, high-precision rotating boring sleeves must be selected to ensure the performance and reliability of the parts. Boring speed. When the boring speed is relatively low, fixed boring sleeves can meet the requirements. This is because, at low speeds, the simple structure and low cost of fixed boring sleeves can be fully utilized. However, when the boring speed is high, rotating boring sleeves must be chosen to avoid excessive wear between the boring bar and the sleeve. For example, in civilian machinery processing, for the boring of some standard parts, if the boring speed is relatively slow, fixed boring sleeves can be used. However, for parts requiring high-speed boring, such as the machining of crankshaft holes in automotive engines, rotating boring sleeves are necessary. Workpiece material and shape. Different workpiece materials and shapes can also affect the choice of boring sleeves. For workpiece materials with higher hardness, the friction between the boring bar and the sleeve is greater, which can easily lead to wear on the sleeve. Therefore, sleeves with better wear resistance should be selected. For workpieces with complex shapes, it may be necessary to choose specially structured sleeves to ensure that the boring bar can smoothly pass through the machining areas of the workpiece. For example, when machining workpieces made of high-strength alloy steel, sleeves with high hardness and wear resistance are required. Meanwhile, for workpieces with deep holes or stepped holes, a combination-type boring sleeve may be needed. Classification and selection of boring sleeves in aerospace and civilian applications, reflecting systematic thinking for precise matching in the aerospace and civilian sectors due to differing performance and quality requirements for products. There are significant differences in the selection of boring sleeves. In the aerospace field, the demands for precision, reliability, and safety of components are extremely high. Therefore, in the selection of boring sleeves, high precision, high performance, rotating boring sleeves are usually prioritized. For instance, in the manufacturing of aircraft engines, to ensure the performance and the reliability of the engine, high precision rolling bearing type rotating boring sleeves are used for the boring of some critical components. This choice reflects the stringent quality requirements and systematic thinking for precise matching in the aerospace sector, where the most suitable type and specification of boring sleeve is selected based on the performance requirements of the product. In the civilian sector, due to the wide variety of products and differing requirements for precision and quality, the selection of boring sleeves is graded based on specific product needs. For some ordinary civilian products with low precision requirements, such as furniture and toys, simple structured, cost-effective, fixed, boring sleeves may be chosen. However, for civilian products with higher precision and quality demands, such as automotive engines and machine tools, rotating boring sleeves are selected. This graded selection approach not only meets the needs of different products, but also reduces production costs, reflecting the systematic thinking in the civilian sector of pursuing economic efficiency while ensuring product quality. In this lesson, we focused on the types and the selection of boring sleeves in boring machine fixtures. Boring sleeves are mainly divided into fixed boring sleeves and rotating boring sleeves. Fixed boring sleeves have a simple structure and low cost, but are suitable for low-speed boring. Rotating boring sleeves can reduce friction and wear, making them suitable for high-speed boring. When selecting boring sleeves, it is important to comprehensively consider factors such as machining precision requirements, boring speed, workpiece, material, and shape. Additionally, through the case studies of graded selection of boring sleeves in the aerospace and civilian sectors, we have appreciated the importance of systematic thinking for precise matching in practical applications. I hope everyone can master this knowledge and be able to correctly select and use boring sleeves in future studies and work.